Work and torque can be a little confusing to distinguish at first. So let's go ahead and look at an example to distinguish the two. And let's start with just some cylinder container. I don't know, we can make this a jar of peanut butter that we're trying to open maybe. Okay, that works. Okay, so we got to open this jar of peanut butter. Let's draw the lines and let's finish this off with a little half circle here, and it's not going to be perfect. And of course, let's draw the lid, the bottom of the lid here. And let's say that this, well, actually, let's go ahead and say this is PB for PB&J, peanut butter. Let's say this thing has a diameter of 3 inches. So from end to end, it is 3 inches in diameter. And let's say we apply 4 pounds of force to crack this thing open, and then I don't know, let's keep that 4 pounds of force consistent as we turn it. Let's draw that force, and it's a circular force, right? So it's going to become some torque which we can measure. And that's kind of half the point of this video actually, is to measure that torque. But we've got this force we're going to apply in a circle, and let's say we have to rotate it, so we have to spin it around twice to open. And so we can measure the work done by this force spinning around this peanut butter jar, and we can measure the amount of torque it would be that we're applying. And so the question becomes, well, what is that torque? And what would be this work, assuming that force is constant along this distance we would travel? And let's start with torque. In our last video, we said our equation for torque would just be the force multiplied by this radius. Okay, so torque equals force times radius. Well, what is the radius? And also, inches isn't a very good unit, since we usually measure radius, we usually measure work and all these. We measure these in feet, not in inches. I mean, we could create some unit for inches if we wanted to, but let's keep things simple, not invent any new units. So then we would have to convert inches to feet. And so to do that, we would have to say, well, okay, we want to convert 3 inches to feet. Well, I know that 12 inches equals 1 foot. And I also know that 3 inches, that's equal to 12 inches. It's 1/4 of 12 inches, right? 3 is 1/4 of 12, therefore 3 inches is 12 inches divided by 4. And if 12 inches equals 1 foot, then I could also say that 3 inches equals 1 foot divided by 4. And 1/4 of 1 would just be, well, 0.25 feet. So this 3 inches is the same thing as saying 0.25 feet in diameter. And if our diameter is 0.25 feet and we know our radius is half our diameter, so our diameter divided by 2, then we could say our radius is 0.25 feet divided by 2. And if we pull out our handy dandy calculator, we can figure out what that is. What is 0.25 divided by 2? And we get 0.125, so our radius is equal to 0.125 feet. And then we can just plug in our numbers. We know that our force is 4 pounds. And we'll multiply that by our radius, which we just got was 0.125 feet. And so what do we get? So we pull back out our handy dandy calculator, and we multiply that 0.125 feet times 4, and we get 0.5. So we could say our torque, therefore, equals 0.5, and then feet times pounds. Let's draw that 5 a little bit closer, make it look nicer. 0.5 foot-pounds. So it requires 0.5 foot-pounds of torque to open this peanut butter. Now what about our work? How is that different? Well, our work is also a force times distance, as we've said before, but that distance is the distance traveled by our force. And if we keep a consistent 4-pound force spinning around this, well, the distance traveled would be 2 times the circumference, wouldn't it? And so we could say, well, what does the distance equal? Well, it's twice the circumference. It has to spin around this circle twice. So distance equals 2 times our circumference. And let's write that out. Circumference. And we could say, well, we know what our circumference equals. Our circumference, the formula for that, let's write circumference correctly. Circumference. Our formula for circumference equals 2 pi r. And we can rewrite this, say 2 times r is our diameter, right? So we could say instead 2 pi r, we could say just pi times our diameter. And that's right, lowercase d, so we don't confuse ourselves. Lowercase d is diameter, uppercase D is our distance traveled. But pi times diameter, okay, and we know what our diameter equals. So we could say this is just 3.14 multiplied by our diameter, which we already solved up here. Again, that's a lowercase d. I keep doing that. So we plug that in right here, and we say, okay, 3.14 times 0.25 feet. And what do we get? When we pull out our handy dandy calculator, we just say, what is 3.14 multiplied by 0.25? And we get 0.785. So let's write that out. Let's say 0.785 feet. And that's just the distance traveled for one time around. If we spun this thing around one time, that would be our circumference, but we said we had to spin it around twice. And so assuming this 4 pounds of force is consistent, it traveled 2 times the circumference. So we could rewrite this equation up here. We said distance equals 2 times the circumference. So distance equals 2 times 0.785 feet. And so we pull back out our handy dandy calculator. We take that 0.785 and we multiply that by 2. And what do we get? We get 1.57 feet would be the distance traveled by our force. And so we just plug that in. We say, okay, equals our force, which again, assuming this is consistent, which is a big assumption, but just to keep our math simple, we'll say that that 4 pounds is consistently applied all the way around as we spin it around twice. We say 4 pounds multiplied by, let's get a right color here, 1.57 feet to spin it around twice. And what do we get? So we pull out our handy dandy calculator again. We say that 1.57 multiplied by 4, and we get 6.28, so equals 6.28, and then feet times pounds is just foot pounds. Obviously, that's our unit that we've been using that hasn't changed. And so this, we could even say, well, we're right up here, our work equals 6.28 foot pounds. And so that's the difference between the work and the torque. They use the same units, but they are not measured the same. Depending on how far our force travels will change what our work could be. And I guess in theory, work and torque could be the exact same. I mean, I guess it wouldn't even be that hard. You just make the force traveled equal to the radius. But essentially, that is the difference between work and torque.